All right, so an inverse is a function that undoes what the original function did. So if the original function took a 1 and turned it into a 2, the inverse function would take the 2 and turn it back into a 1. So that's the whole idea of inverse functions. And to do that, you use inverse operations. And just try to remember, the inverse operation of exponential is logarithmic, and logarithmic is exponential. Okay, so the steps are there, but I'm going to see if you guys can remember what to do without the steps. So what is the first thing you do whenever you find an inverse? You do something with x and y. Switch x and y. That's the first thing you do. So make the y an x and make the x a y. And then do all the algebra you have to do to solve this for y. So the first thing you want to do is get the exponential expression by itself. So there's two things I need to do first before I do that, or to do that. All right. And then we learned this the Friday before we got out for all those 12 days. So we need to do something so we can get that y down. How do we do? What do we do? How do we do that? There's only one way to get in. Well, actually, there's two ways. In this case, there's only one way to get that exponent down. And it's to use logarithms. And so we are take this and write it in logarithmic form. So we'll start with the word log. What is the base of our logarithm going to be? 2. What is the argument going to be? X plus 15 over 3. And remember, a logarithm always equals the exponent. So someone in my last class, she's like, sometimes I still get confused about where to put what. So just trying to remember that a logarithm always equals the exponent might save you some time. You can also, if you want to do that loop that you guys learned in Algebra 2. But we're almost done. There's one more thing we need to do, and it's to subtract that 4 and write our answer in inverse notation. So if the original function was f of x, this is going to be f inverse of x, which looks like f to the negative 1. All right, and that's it. So that function would take everything that f does and undo it. Like it never happened. All right, what questions do you guys have on that one? So the inverse of exponential is always going to be a logarithmic function. And right now, we're about to find the inverse of a logarithmic function. It's definitely going to be exponential. So we're going to start off the same way. We're going to switch x and y and solve for y. All right. And our first goal is to get the logarithmic expression by itself. So that, again, there's two things we need to do. Okay. Now, we need to divide by this negative 3. Now, one thing, like on a multiple choice test, I don't think you would ever see an expression that looks like that, where there's a single negative integer in the denominator. That's just not how it would be written. Sometimes you might see maybe the negative out front, but most of the time what happens is that negative is distributed in the numerator. So that's what I'm going to do. I'm just going to distribute that negative in the numerator. Right. The other thing you're probably not going to see is if it's negative x plus 6, most likely on a multiple choice, they would switch that, bless you, and make it 6 minus x. they mean the same thing on free response, I would give you full credit for leaving it like this, but probably multiple choice, they would switch the order. So that I'll switch the order on the next one. All right, so once we have the logarithmic expression isolated, now we're going to write it in exponential form. So it would be 5. And then if you want to draw the loop, you can. Or you can just remember a logarithm always equals the exponent. So our exponent is going to be 6 minus x over 3. And that should equal y minus 4. All right, our last step is just to add that 4 and go ahead and write it in inverse notation. That's it. All right, what questions do you guys have on this one? Good. All right, so we have one more inverse question and we'll get into the inequalities. But we know what h of x is, and then we're told that k is the inverse of h. And so it asks for what values of x does k of x equal 1? And so 1 ends up being the output of the inverse, because k is the inverse. So what should it be on h? It's the output of the inverse. What would it be on h? The original. It should be the input. So what starts off looking like kind of a difficult question, like you'd have to find the inverse and do a bunch of junk, ends up not being too bad. So all we have to do is go back in our h and just put 1 in for x. And we get 7. So to write your answer, you would say k of 7 is equal to 1. All right. Now that doesn't seem too difficult right now. After we keep learning a whole bunch of stuff, that might be hard to pull back out of your brain. But just try to remember that just the input and output are switched. All right, so let's talk about these inequalities. So we learned about solving polynomial and rational inequalities earlier in the last semester. So polynomial wasn't too bad. You found where the polynomial is equal to 0, and then you tested points in each region. We did the number line. It wasn't too bad. The rational functions were a little more difficult because you had to find the zeros, but then you also had to find the holes and the vertical asymptotes and test a bunch of points. So we're going to do kind of that same thing with logarithms. In the end, I think it's going to end up being a little easier than what we did with the rational functions. You don't have as many things to do. The thing I'm the most concerned about is with the domain. So if you guys remember, these arguments have to be greater than 0. So x plus 3 is greater than 0. That's super easy. We could do that all day long. We know that x has to be greater than negative 3. But you don't know what x squared minus 4x plus 7, I mean, you probably know it's a parabola, but you don't know exactly what it looks like. It's not something that we could factor. And so if we were having to do this question without a calculator at all, we would have to do a quadratic formula. It would be a super big mess. So what I'm going to have you guys do is just check what this looks like in the calculator. We need to find where it's greater than 0. Right, so in this case, we're not typing in the log. We're just going to type in that function. Yeah, I guess go ahead and grab a calculator. There are other things we're going to do in this lesson that it would be helpful for you to have one. But most of the stuff we're going to try to do without one. All right, so that's what that parabola looks like, which is great because it's always greater than 0. So we don't have to worry about like shortening the domain. So we can use any x for that one, for this part. And then for this part, we have to use x's that are just greater than -3. Now, since it's one big function, we have to use x's that are greater than -3. All right, so I'm going to make a note that this is always, oops. Okay, so we don't really have to worry about that for our restrictions on the domain. Now, just like we did with other types of functions, we're going to do a number line. This number line is not going to have an arrow pointing in both directions, though. This number line is going to have an endpoint on one side, and we can only start with x's that are greater than -3. All right, let that sink in for a second. That's kind of different. So whatever your restrictions are for your logarithm, that's where your number line starts, because those arguments can't be negative or 0. All right, so what we're going to have to do is bring these logs together. So we're going to rewrite our function as a single logarithm. And since they're separated by subtraction, we're going to bring them together using division. And our goal is to find where this function f of x is greater than 0. So what we're going to do, just like we did with polynomials, is we're going to find when f of x equals 0. All right, so I'll take our logarithm and set it equal to 0. And those are the points that we're going to have to put on our number line. All right, so we have a logarithm equals a number. So this is the type of logarithms that we would write in exponential form. What is the base of our logarithm? 10. So it would be 10 to the 0 equals that fraction. What is 10 to the 0? Yep. All right, I'm running out of room, but that's okay. All right, so I'm going to go ahead and multiply by that x plus 3. And get everything on one side and factor it. Okay, so as long as those numbers are greater than -3, which they are, we would label them on the number line. And then we're going to test a point in each region. All right, so everywhere between -3 and 1 will have the same sign. And then it becomes like the value becomes 0, and then it could change to a different sign. So that's why we test in each region. So I'm going to start off and put in 0, 2, and 5. Now, what's nice about this is we don't have to go back to the original function to figure out positive and negative. We actually can just use these factors. So for 0, I can just plug it into this one. So if I put in 0, I'm going to get 4, which is positive. Right, but then when I put in 2, I can plug it in here and here. So when I put in 2 to the first one, I'm going to get a negative. And then when I put it into this one, I'm going to get a positive. And when I multiply those, I know it's a negative. And then we'll do 5. All right, and then I'm ready to answer the question. The question was where, or for which values of x is f of x greater than 0? All right, so that's going to be in the interval from -3 to 1, and then from 4 to infinity. Right. And one thing I didn't do, and I forgot to do it last period, is to do the open and the closed circles. I should have. So if this doesn't have or equal to, they're all closed circles. And the one at this number, the endpoint, has to be an open circle. I might have said closed. I meant to say open. So no or equal to is all open. That one has to be open because x can't be -3 because then it would not be in your domain. All right. Oh, I want to show you, there are a couple of questions on your homework that I just straight tell you to do it in the calculator. And so I want to show you how to do that. If this question was to use a calculator to solve, what we would do is just plug the function in to y1. Do you guys know how to do just log? We haven't done it a lot on the calculator. It's just the button beside 7. So that should be it. All right, now you will need to figure out where this endpoint is. You might be able to do that in the calculator, but you probably would have to do the domain. And so we want to know where this is. I keep forgetting. Where it's greater than 0. And so where it's above the x-axis. So you would need to find where it equals 0. There's 2 ways you can do that. If it crosses exactly at a point, you can just go to the table and see it's 1 and 4. If it's at a decimal, do you guys remember how to calculate a 0? Nobody's talking to me today. It's kind of weird. So to calculate a 0, you hit second trace and then number 2. And you get that little flashing cursor. And you hit enter on the left side and enter on the right side. So right now, if I'm looking at this first 0, I am on the left side. So I can hit enter. And then I'm going to cross over to the right side. Now, when it's not very steep, sometimes it's hard to tell if you've crossed over. So what you can do is see that right now the y is positive. I'm going to cross the x-axis whenever the y changes to negative. So there, I know it's negative. So I can hit enter. And then enter one more time. And so that's going to be the 1. All right. Next question is different. So we have 2 functions this time. We want to know when g of x is less than h of x. So I want to know when the natural log of the quantity x squared plus 2 is less than the natural log of x plus 4. So even though this is a different question, we're going to do the number line and everything. So let's look at our arguments. So this x squared plus 2, is that ever going to be 0 or less than 0? If you square a number and add 2 to it, will that ever give you a negative or 0? No. So this one is always greater than 0. This one, x plus 4, must be greater than 0, so x is greater than negative 4. So I know on my number line, negative 4 is going to be on the left. I can't go past it. Okay, so just like before, if I want to find where one is less than the other, I need to find where they're equal to each other. And then we learned how to do this a couple of days ago. So what do you do when you have a log equals a log? Cancel out the logs, and you're just with the arguments are equal to each other. All right, so we're going to get everything on one side. And then factor. And then as long as those numbers are greater than negative 4, which they are, we would put them on the number line. And we're going to test a point. And just figure out if we get positive or negative. Now, in this case, because I want to know when one is less than the other, the answer we're going to want is going to be where we get negative. All right, so I'm looking here. I'm going to put negative 3 in for both of those factors. I'm going to get a negative times a negative. Now, when I put 0 in, it's okay to go to this one, and I know I'm going to get negative 2. And then when I put 3 in, I'm going to get a positive times a positive. I didn't have any or equal to, so these are definitely open circles. So g of x is less than h of x whenever I get a negative here, which is going to be from negative 1 to 2. All right, and I am also going to show you how to do this one in the calculator. All right, so this time what I'm going to do is put g of x in for y1. So natural log is just right underneath the log button. And then h of x in for y2. All right, so my y1 is blue and my y2 is red. So what we're looking for is when blue is underneath red. And you can see it's a small section right here. It happens to be what we found between negative 1 and 2. Now, if you can't tell, like if it's at a decimal, you would want to find where those two intersect, which is going to be second trace number 5. And then you just move close and hit enter 3 times. And it gives you that intersection point. All right. All right, and then one more thing. On your assignment, I think there's one you do in the calculator that's log base 2. Do you guys know how to get log base? All right, it's alpha window. So you might jot that down somewhere in your notes. Alpha window 5 is log base. All right, we got one more, and different than normal. Usually the problems get more difficult as you go down. I think this one is way easier than the two we just did. So we're saving the easiest one for last today. All right, so this is an exponential inequality. We want to know when that k of x is less than or equal to 31. So I'll just take it and I'll set it less than or equal to negative 31. And then just use algebra to figure it out. So I'm going to start off and isolate my exponential expression by subtracting 1. And then dividing by negative 4. But what do you have to do when you divide by negative? Change the inequality sign. Very good. All right. So what do you guys think we do here? What would you do if that was an equal sign? Turn it into a like basis. So we want to, well, I guess we could do a logarithm. We could, but it's easier, I think, to write 8 as 2 to a power, and 8 is 2 to the third power. And then instead of setting the exponents equal, we're going to set them greater than or equal to. And then that last step is just to add that 3, and that's the answer. Thank you. All right, I feel like this is a lot for a Friday. What questions do you guys have?